Hello everyone, and welcome. I'm excited to have you here for today's presentation. We're about to dive into a beginner-friendly exploration of how the internet works. On this first slide, you'll see the title Faceless, No Voice, Text plus Animation Style, which hints at the visual approach we'll be using. Over the next approximately 10 minutes, we'll cover key concepts like client-server, DNS, HTTP, and how these components come together to make the internet function smoothly. So, let's get started and uncover the fascinating world behind our everyday online experiences. That's what this video is all about. When you type in google.com, for example, do you ever wonder what actually happens behind the scenes? Well, it turns out that this process occurs over 100 times a day for most of us. We use the internet so frequently that we often don't think about the incredible amount of technology and communication that happens in just a split second. Understanding this process helps us appreciate how seamlessly our digital world operates and sets the stage for the rest of this presentation. Let's take a closer look at how websites work behind the scenes. On one side, we have the user's browser, which is what you're using right now to access the internet. Think of it as the client that requests information. On the other side, there's the server, which is a powerful computer that hosts the website's data. When you type in a URL and hit enter, your browser sends a request to the server. The server then processes that request and sends back the information needed to display the website on your screen. This interaction between your browser and the server is fundamental to how the web operates. Each website interaction actually has two sides: the client side, which is your browser, and the server side, which is the website server. Understanding this basic exchange helps us see how data travels across the internet and how websites are delivered to us seamlessly. It's a simple but crucial concept that underpins everything we do online. Let's walk through this slide together. Think of a client like you or me sending a request, say, asking for a menu item. The server, which is like the restaurant's kitchen, processes that request, preparing the food. Then the server sends back the response, delivering the food to the customer, or in our case, the web page or data you asked for. In this analogy, the HTTP request is like the waiter taking your order, and the HTTP response is like the server bringing your food. The food itself, represented here by pizza, is the data or information we get in return. The key idea is that this cycle, request, process, response, is how the web communication works behind the scenes. It's like a well-oiled restaurant where your order is processed quickly and efficiently. Connecting this to the overall theme, understanding this client-server interaction helps us see how data travels across the internet, making everything from loading a web page to streaming a video possible. All right, let's walk through what happens when you type a URL into your browser and hit enter. First, the browser checks if it already has this website stored in its local cache. If it does, it can load it much faster without going to the network. If not, it needs to find the server's address, which is where the DNS comes in. The browser contacts the DNS server to ask, "Hey, what's the IP address for google.com?" Once it has the IP address, it sends an HTTPS GET request to that server saying, "Hey server, send me your homepage." The server then responds with all the necessary files, HTML, CSS, JavaScript, that the browser uses to render the page you see. And finally, the browser takes those files and displays the web page. This entire process is what we call the URL journey, and understanding it helps us see how each step is crucial for loading websites efficiently and securely. All right, let's dive into slide 6. Here, we're looking at how the domain name system, or DNS, functions like the internet's phonebook. It translates human-readable domain names like www, example, .com into the machine-readable IP addresses that computers use to identify each other on the network. Think of it as a system that helps us find websites easily without having to remember complex numbers. The slide shows a simplified diagram: the system, the name, the domain, and the DNS itself. The key point is that DNS acts as a directory. When you type in a website address, your device queries the DNS to find the corresponding IP address. Without this system, navigating the internet would be much more cumbersome. So, in essence, DNS makes the internet user-friendly by bridging human language and machine language, keeping the entire network connected smoothly. This is a fundamental part of how we experience the internet today, making it accessible and easy to use for everyone. Let's look at this slide and see how it all connects. On the left, we have Google.com, which translates to the IP address 14225019046. This shows how a domain name like Google.com is mapped to its numerical IP address. Now on the right, we see an old phonebook example. Instead of domain names, it lists a person's name, John Smith, alongside their phone number, 5554242. The key point here is that DNS, or domain name system, works just like a phonebook. It helps us find the IP address associated with a domain name, much like looking up a person's phone number by their name. This analogy makes it easier to understand the function of DNS in the Internet's infrastructure. Just like a phonebook connects names to numbers, DNS connects domain names to IP addresses, enabling us to access websites easily without memorizing complex numbers. So the main takeaway is that DNS simplifies navigation on the Internet, acting as a universal directory that translates user-friendly domain names into the technical IP addresses our devices need to connect. All right, let's take a closer look at how DNS lookup actually works in real time. As you can see, all three lookups, whether it's the IP address, the root server, or the ISP's DNS server, are completed in under 50 milliseconds. That's incredibly fast, and it highlights just how efficient the DNS system is. When you type in google.com, your browser sends a request to your ISP's DNS server, which then starts the process of resolving that domain name into an IP address. It first checks its cache. If it doesn't have the answer, it reaches out to the root server, like the global directory of the Internet. The root server knows where to find the authoritative servers for top-level domains, like .com. From there, the process continues with the DNS resolver, which asks the appropriate servers until it finally retrieves the IP address. In this case, 14225019046. And all of this happens seamlessly and in a blink of an eye, usually in well under 50 milliseconds. This flow is the backbone of how we navigate the Internet quickly and efficiently. It's what makes browsing smooth, and it's a key part of understanding the magic behind our everyday online experiences. All right, so here on this slide, we see that the green IP address is actually what your browser connects to when you visit a website. This is the server that handles your request and delivers the web page. In this example, the domain name is google.com, but what your computer actually works with behind the scenes is this numerical IP address, which is 14225019046. Then there's a non-authoritative answer shown here, which indicates that the address 192.168.1.1/53 is coming from a local DNS server, probably your router or local network. This server, in turn, is responsible for translating google.com into that IP address. You see the command enslookup google.com. That's a tool you can use in the terminal to perform this DNS lookup yourself. It's a hands-on way to see how your device finds the IP address associated with a domain name. And I encourage you to try it yourself right now, so you can get a feel for how this process works in real time. This connection between domain names and IP addresses is fundamental to how the Internet functions smoothly and efficiently. So every time you visit a website, there's actually a lot happening behind the scenes. One of the key components is something called HTTP, which stands for Hypertext Transfer Protocol. This is basically the language that your browser and the website's server use to communicate with each other. Think of it as a set of rules or a common language that helps them understand each other clearly. When you click a link or enter a website address, your browser sends a request using this protocol, and the server responds accordingly. It's like a conversation where both sides know exactly how to send and receive information smoothly. This protocol is essential because it ensures that your browsing experience is seamless and that data moves efficiently between your device and the website. So every time you're surfing the web, remember, HTTP is quietly at work making sure everything connects properly. So here we see an example of a typical HTTP cycle using a restaurant analogy. When you place an order, it's like sending an HTTP request. In this case, the request is a GET request, asking for the home page. You can see the request details, such as GET HTTP11, which indicates you're asking the server to retrieve the home page. Then, once the server processes your request, it responds with a status code, like 200 OK, along with the HTML content of the page. Think of it as the waiter bringing your food. Your request has been fulfilled successfully. This cycle of asking and answering, in other words, sending a request and receiving a response, is the core of how HTTP works. It illustrates the fundamental communication process between a client and a server, which is essential for web browsing and data exchange. Understanding this cycle helps us grasp how web pages load and interact seamlessly. Let's talk about the importance of always using HTTPS when browsing online. You'll notice in your browser bar, a padlock icon appears. That's a quick visual cue that your connection is secure. When you see that padlock, it means your data is encrypted, making it readable only by you and the server you're communicating with. This encryption is achieved through SSL or TLS protocols, which add a protective layer to your data transmission. Now, compare that to HTTP without the S when you're using HTTP. Anyone on the same network can potentially read your data because it's unencrypted. This makes your information vulnerable to eavesdroppers or man-in-the-middle attacks. So the key takeaway here is, always look for that padlock symbol and choose HTTPS. It ensures your data stays private and protected, which is a fundamental part of maintaining online security. Remember, secure connections are a crucial part of the overall theme of safeguarding your digital information. Let's take a closer look at some common HTTP status codes and what they mean. When a server is overloaded or temporarily unavailable, you might see a 503 service unavailable message. This indicates that the server is crashing or has broken down, and it's not able to process your request right now. If you encounter a 500 server error, it usually points to a problem on the server itself. Something went wrong unexpectedly. Moving on, if you try to access a page you don't have permission for, you'll see a 403 forbidden message. That means access is denied, perhaps due to restrictions or security settings. Next, if a page doesn't exist at all, you'll encounter a 404 not found error. It's a clear sign that the resource you're looking for isn't available on that server. Sometimes, pages are moved to a new URL, and in that case, you'll see a 301 moved permanently status, telling you the page has a new location. On the positive side, when everything loads correctly and smoothly, you'll see a 200 OK message. This confirms that the page has loaded successfully and everything is functioning as expected. Understanding these status codes is crucial because they help us diagnose issues quickly and understand the communication between our browsers and servers. They are fundamental to web development, troubleshooting, and ensuring a smooth user experience. All right, let's bring everything together and see the full picture. On this slide, we have a simple equation. The full picture equals, and then we see these key components. First, HTTP or HTTPS. That's how our browsers communicate with web servers, whether securely with HTTPS or normally with HTTP. Then we have DNS lookup, which is like the phone book of the internet, translating those easy-to-remember domain names into IP addresses that computers understand. Next, we have client-server, which is the fundamental model where our devices, the clients, request information from servers that host the websites or services we're accessing. Putting it all together, these pieces work seamlessly to deliver the content we see online. When you type a URL, your browser initiates a DNS lookup, then makes an HTTP or HTTPS request to the server, and the server responds with the data. which your browser then displays. Understanding how all these parts connect helps us appreciate the complexity behind what seems like a simple web page load. It's this full system that underpins our entire online experience. All right, so at this stage, we've reached the exciting part where the browser finally renders the web page, and you get to see the actual content. Party popper, this is the culmination of the entire process we've been discussing. Here's what happens. The browser receives the HTML, CSS, and JavaScript files from the server. These files contain all the instructions needed to display the web page correctly, from layout to interactivity. Once the browser has these files, it processes them and renders the page on your screen, allowing you to interact with the website seamlessly. It's important to understand that this entire flow, from you typing in a URL to seeing the web page, relies on multiple steps working together efficiently. Each part plays a crucial role in delivering a smooth web experience, and that's what makes the whole process so fascinating. Did you know that a human blink typically takes about 150 to 400 milliseconds? That's roughly a quarter of a second or even a little more. Now, compare that to the internet. It's often faster than you can blink. In fact, the entire process of loading a web page can happen in just 0.2 seconds or 200 milliseconds. All 7 steps involved in transmitting data, like requesting, sending, processing, and displaying, happen within that tiny fraction of a second. This really highlights just how incredibly fast digital communication has become, and it's a key part of understanding how seamlessly and instantaneously information flows today. All right, let's walk through the process that happens when you click a link or type a URL into your browser. It all starts with you entering the address, which is step 1. From there, your browser needs to find the right server, so it performs a DNS lookup to translate that URL into an IP address. Once it has the IP, it sends an HTTP request to the web server, asking for the web page. The server then processes this request and sends back the files, like HTML, CSS, and JavaScript, that make up the page. As these files arrive, your browser begins to render the page, displaying it on your screen. And finally, the response travels all the way back to your browser, completing the cycle and showing you the web page you asked for. This entire process is a great example of how different components work together seamlessly to deliver content quickly and efficiently. All right, let's take a closer look at what happens behind the scenes when you access a website. All of these steps, all 7 of them, actually happen in less than 200 milliseconds. That's faster than you can blink. First, when you type in a URL, your browser uses HTTPS, which is basically HTTP plus encryption. Always choose HTTPS whenever possible because it keeps your data secure and private. Now, HTTP is the language that browsers and servers speak to each other. It's how they communicate requests and responses. To find the right server, your device uses DNS, or Domain Name System, which translates human-friendly domain names into IP addresses that computers understand. Once the connection is established, your client, meaning your device, sends a request to the server asking for specific data. The server then responds by sending back that data, completing the cycle. So, in a nutshell, these quick steps, encryption, language, translation, request, and response, are all essential for a seamless browsing experience. They happen so fast that we hardly notice, but understanding this process helps us appreciate the complexity behind what seems simple on the surface. That's real knowledge. When we talk about the full browser-to-server-to-browser cycle, we're really understanding how every request and response flows back and forth. This cycle is fundamental to how the web works. Next, why does HTTPS matter for security? Well, HTTPS encrypts the data exchanged, protecting sensitive information from eavesdroppers and man-in-the-middle attacks. It's essential for keeping user data safe. Then, what do HTTP requests actually look like? They're structured messages sent from your browser to a server, asking for resources like web pages or images. Understanding their format helps us troubleshoot and optimize communication. Moving on, how does DNS resolve domain names? When you enter a URL, DNS translates that human-readable address into an IP address that computers use to locate the server. It's like the phone book of the internet. And finally, what is a URL really? It's a uniform resource locator, a complete address that tells your browser exactly where and how to access a resource on the web. Most developers take these concepts for granted, but now you understand the core mechanics behind them. This knowledge is what empowers you to build more secure, efficient, and reliable web applications. Now, moving on to slide 20 out of 22, which is part of our Basic to Advanced series. Here, we're focusing on the idea of the bridge between applications, and I want to explain this in a simple way. So, what exactly is an API? Think of an API, or Application Programming Interface, as a set of rules that allows different software applications to communicate with each other. It's like a bridge that connects different systems, enabling them to share data and functions seamlessly. This is a key concept because it underpins how modern applications work together, making integrations smooth and efficient. As we continue through this series, you'll see how APIs are fundamental in building complex, interconnected digital ecosystems. Up next, we have video 2, where we'll dive even deeper into how APIs work in real-world scenarios. Stay tuned, because understanding APIs is crucial for grasping the bigger picture of application development and integration. Alright, if you're looking to deepen your coding skills, we've got more beginner videos coming your way. These are uploaded weekly, so there's a steady stream of new content to help you learn. The videos cover a wide range of topics, from the basics to more advanced concepts, ensuring there's something for everyone no matter where you're starting from. If you want to access even more example snippets and quick tips, be sure to subscribe. Subscribing helps you stay updated with all the latest content and ensures you don't miss out on any new tutorials. And if this content has been helpful to you, I'd really appreciate it if you give it a thumbs up or let others know. Your support helps keep this content coming and makes it easier for others to find. Thanks for watching and keep coding. Now, as we wrap up this series, let's look ahead to the next topic. What is an API? APIs are essential tools that allow different software systems to communicate with each other seamlessly. They act as bridges, enabling applications to share data and functionality in a secure and standardized way. This understanding will deepen your grasp of how the internet works behind the scenes, making it easier to build and innovate. Remember, throughout this series, we've been learning how code powers the digital world, learning, building, and creating with purpose. So, stay curious and keep exploring how these building blocks connect to form the technology we rely on every day.